Welcome everyone. Welcome to NS Institute. In this class, we will learn regarding the solar cell. So, basically, what is a solar cell? The solar cell is actually one kind of photovoltaic cell. That is, it is the photovoltaic device that convert the light energy which is actually coming directly from the sunlight into the electrical energy. That is, solar cell is one kind of photovoltaic cell that converts the energy of sunlight directly into the electricity by the use of photovoltaic effect. So basically, this device, that is the photovoltaic device, is working on the principle of photovoltaic effect. And what is a photovoltaic effect or photovoltaic device? The generation of voltage across a p-n junction. P-n junction means that the junction of p-type and n-type semiconductors due to the absorption of light radiation is called photovoltaic effect. This is actually a physical phenomenon. No any kind of chemical reactions is being performed on this kind of situation. This is only one kind of physical phenomena. And the devices based on this effect is called photovoltaic device. Okay, so now we will learn about the working principle of this solar cell. Now the solar cells are based on the principles of photovoltaic effect. We have already learned this so far. And the photovoltaic effect is the photo generation of charge carriers in light absorbing materials as a result of absorption of light radiation. So basically, what is happening? So this is the overall diagram or the sandwich diagram of photovoltaic cell. So here, a solar cell is a sandwich of two different layers of silicon that have been specially treated or doped so that they will let electricity flow through them in a particular way. Now the lower layer, this one, the lower layer is doped so it has slightly too few electrons. So it is called p-type or positive type silicon. So this is the lower layer, right? This is the p-type silicon, or you can say that positive type silicon. So basically it's a sandwich type. So there will be a lower layer and another will be a upper layer. And this upper layer is doped the opposite way. So this is the upper layer. This upper layer is doped the opposite way to give it slightly too many electrons. So therefore, it is called a n-type or negative type silicon. So basically, it is a sandwich type of structure. The lower layer is the p-type or positive type silicon, and the upper layer is the n-type or negative type silicon. Now, we will look a little bit regarding the construction of solar cell. So whatever we have already learned, that solar cell consists a n-type semiconductor, that is a emitter layer, and a p-type semiconductor, that is a base. So these two layers are actually sandwiched, and hence there is formation of p-n junction, and the surface is coated with anti-reflection coating. Sorry for this spelling mistake. So the surface is coated with an anti-reflection coating to avoid the loss of incident light energy due to reflection. See that what will be happen, that basically it is a physical phenomena. This sunlight, this energy of the sunlight will be absorbed, and then this energy will be converted into the electrical energy. But now when this sunlight is coming over this solar panel, if the light will be reflected, then what will be happened, then some percentage of the energy of that incident light will be reduced, right, or will be lost and therefore the efficiency will be less. So therefore the surface is coated with one kind of anti-reflection coating, so that the loss of this incident light energy is avoided. So the efficiency would be increased as much as that sunlight or the energy of the sunlight will be absorbed, the efficiency will be increased of that solar panel. Now, a proper metal contacts are made on the N-type and P-type side of the semiconductor for electrical connection. Now, we will look a little bit regarding the construction of solar cell. So, whatever we have already learned, that solar cell consists a N-type semiconductor, that is a emitter layer, and a P-type semiconductor, that is a base. So these two layers are actually sandwiched, and hence there is formation of P-N junction, and the surface is coated with anti-reflection coating. Sorry for this spelling mistake. So the surface is coated with an anti-reflection coating to avoid the loss of incident light energy due to reflection. See that what will be happen, that basically it is a physical phenomena. This sunlight, this energy of the sunlight will be absorbed, and then this energy will be converted into the electrical energy. But now when this sunlight is coming over this solar panel, if the light will be reflected, then what will be happened, then some percentage of the energy of that incident light will be reduced, right, or will be lost, and therefore the efficiency will be less. So therefore the surface is coated with one kind of anti-reflection coating, so that the loss of this incident light energy is avoided. So the efficiency would be increased as much as that sunlight or the energy of the sunlight will be absorbed, the efficiency will be increased of that solar panel. Now, a proper metal contacts are made on the N-type and P-type side of the semiconductor for electrical connection. So now, what are the advantages of solar cell? Now, we will discuss a little bit regarding the working of the solar cell, that is how the solar cell works. Now, when a solar panel is exposed to sunlight, that is when the sunlight or this sun shines, so basically the sunlight will come over the solar panel. So the solar panel will be exposed to the sunlight, and the light energies are then directly absorbed by the semiconductor materials. Whatever the semiconductor materials will be used in the solar panel. So due to these absorbed energy, the electrons are liberated and produce the external DC current. So type of the current will be DC. Now as the DC current will be produced, it should be converted into the AC current, right? That is, it should be converted to the AC current, and the conversion will be possible only by the use of an indicator for different applications. Now we will discuss a little bit more brief. So, solar cell generates electricity by using sunlight to make electrons hop across the junction between p-type and n-type silicons. So as we have already discussed that it is having a sandwich type of structure, the above layer will be like n-type silicon, and the lower layer will be like p-type silicon. That is, the positive type silicon will be the lower layer, and the upper layer will be like the n-type or negative type silicon. So these when these sun shines, or you can say that when the sunlight shines on the cell, that photons, or you can say that light particles bombarded the upper surface, right, and then carry their energy down through the cell. When the sun shines, the light will be means these lights, or you can say that photons or light particles bombarded the upper surface of the solar panel, and they carry their energy down through the cell. Now first the photons will give up their energy to the electrons in the lower p-type or p-type layer. Now the electrons then use this energy to jump across the barrier to the upper n-type layer, right? So from p-type to n-type, the electron will jump, and then therefore this electron will escape out into the electronic circuit. Now flowing around the circuit, the electrons make the lamp light up. So due to the flow of the electrons, the electricity will be generated, and therefore the lamps will light up. Okay, so this is the overall principle, that when the sun shines, the solar panel will be exposed to the sunlight, so therefore the photons, or you can say the light particles, will actually bombard the upper surface, and these photons will carry their energy down through the cell. Now the photons will first give the energy to the p-type layer, to the electrons of the p-type layer. Now the electrons will absorb this energy, and then these electrons will jump across this p-type to n-type layer, right? So as the electrons will jump from this p-type to n-type layer and escape out into the electronic circuit, the flowing of the electrons will be generated, that is the electricity will be generated, and the lamp will light up. So this is how the solar cell is actually working. It is very clean and non-polluting, right? So no other harmful chemicals are being generated, so therefore it is completely clean and not creating any kind of pollution. It is a renewable energy source, right? So as it is a physical phenomena, and as it is directly converting the energy of sunlight into the electricity or electrical energy, so basically it is a renewable energy source. Now, solar cells do not produce any kind of noise. It is comparatively quiet in nature, and they are totally silent. They require very little maintenance cost, though the installation cost will be comparatively higher, but the maintenance cost is comparatively cheap. They have long lifetime, and there are no fuel costs at all or fuel supply problems, as it is directly absorbing the sunlight and then converting that energy into the electricity or electrical energy. So therefore there are no fuel costs or fuel supply problems. Now we'll look into some of the disadvantages of solar cell. Now, these solar cells or solar panels are actually very expensive. Whatever I was telling in the last slide, there the maintenance cost is actually cheap, but the installation cost is more. So therefore, it is actually very expensive. The installation cost will be higher side. The energy has not be stored in batteries, so only whenever this conversion means that conversion is possible, but the storing is not possible. The energy cannot be stored, and this air pollution and weather can affect the production of electricity. Again, sorry for the spelling mistake. This air pollution and weather can affect, because it is only dependent upon the light energy or light energy of the light particle. So therefore the sunlight is mandatory. So when there will be any kind of this air pollution, or if the weather is not that much friendly, for example if it will be a rainy season, then it can affect the production of the electricity. They need large area of land. They need large area of land to produce more efficient power supply, because this solar panel needs a large area for the installation. Now the sun doesn't shine consistently, right? Because the weather can be changed, so therefore the sun cannot shine consistently, so it will affect the solar cell. Now it is actually less efficient and costly equipment. The installation cost will be more, and reliability depends on location also. So basically, these typical solar shells are only about 15% efficient. So we can only capture a fraction of this theoretical energy. So that is why solar panels need to be so big. The amount of power made is obviously directly related to how much area is affordable to cover with cells. If you are taking a single solar cell, roughly the size of a CD, can only generate 3 to 4 or 4.5 watts. A typical solar module made from an array of about 40 cells. 40 cells means you can take like this 5 row with this 1 2 3 4 5 6 7 8. So like these 5 rows of 8 cells could make about 100 to 300 watts only. So several solar panels made from about 3 to 4 modules could therefore generate an absolute maximum of several kilowatts. So basically what I am trying to say that these solar cells are actually very less efficient, means that they are mostly 10 to 15% efficient. So to capture means it can only capture a fraction of this theoretical energy. This is why solar panels should be bigger in size. The area should be more because you have to install in a bigger area, so that the amount of power made is actually large and will be useful in nature. So obviously this amount of power made is directly proportional to the area which is affordable to cover the cells. So basically you need the larger area for installation, right? So these are the disadvantages of solar cell. Now we'll finally go through the applications of this solar energy. It can be applied for the domestic power supply, or you can use these for this electric power generation in space, for drying agricultural products, or you can say that solar pumps are used for water supply, for water heating, generating electric power, and to provide electrical power to satellites. So these are the most of the important applications of solar energy. So thank you very much for watching this video. If you like this video, please share this video as much as possible and subscribe our channel. And the study material link will be given in the description box. You can click on the link and get the study material easily. And once again, thank you very much for watching this video. See you in the next class. Bye bye.